Hello and welcome to Pygame for Beginners Summer Camp Sugar Smash. Pygame is a lot of fun. It's like the MacBook Pro of programming. It just works. This course is a short course in basically creating a small program, getting Pygame up and running. The purpose of this course is to give you enough skills to get beyond the beginning of the learning curve, get over the hump, and start making your own projects. If you're really keen, you can get this done in about a day or a weekend. However, my recommendation would be to take your time, at least about a week with it, to really let the concepts sink in. I hope you're excited as I am to get into it and start learning Pygame. And yeah, join me in the next video where we get things up and running. See you soon. Hi, welcome back. So to get things started, for this course I'm going to be using Visual Studio Code. We go VS Code. We can find it here. We can just go to download and go to Windows, user installer 64-bit, and this will download Visual Studio Code Community Edition, I believe, the free edition. But really anything is fine. You can do all of these with like Sublime Text or Atom or any text editor. You can even do it in idle if you want, no problem. So nothing too special there. The other thing we're going to need is Python. And we can go to python.org and go to downloads 3.9.7. And we can just download that installer and run it. There's no problem there. The only thing that's really important is, I'll go through this, why not? I haven't downloaded Python in a while. Okay, so we're back. I just uninstalled Python and I'm reinstalling it right now to show the proper installation process. So when we go to install, we have this screen, and most of the time it's just clicking through, but this is really important. We need to click Add Python 3.9 to Path. That is so that when we go to install Pygame, we can just use pip, and the command terminal basically understands what pip is. Okay, so we click Add Python 3.9 to Path, install, yes, that's fine. So we should have that installed and we are good to go. Now what I do is I keep a folder on my computer called dev for all my development stuff. That's a good habit to get into. I'll jump in here, we'll go to Python and we'll make a new folder for our project. And we are going to call it Sugar Smash All Stars. Awesome. Okay, so we'll click into that folder. And now what we could do is we could open this in VS Code, or I'm going to right click and it says here open with code. That's a cool little trick. So we bring this up and it says, do we trust the authors? Well, I am the author, so yes, I trust it. Okay, now we'll go new file, and VS Code lets you create in all sorts of languages. To create a Python file, we'll call this main, and we need to end it with .py. That creates a Python file. So here we are, and we can see down here we're going Python 3.9.7, that's good. Now we open up a new terminal and we want to install Pygame. So we'll use Python install package, pip, install Pygame. I already have it, so it tells me that, yep, we already have it, no problem. And then, as always, it tells us to upgrade pip. We don't need to upgrade pip, it's not necessary. Okay, so let's go import Pygame. And what I like to do is I like to abbreviate it, import Pygame as PG. So then Actually, let me just run this and check. We run it and it says, hello, welcome from the Pygame community. So that's it. There's no errors. It works. That is great. I'll just call this function here to start. Pygame initialize just sets Pygame up so it's ready to go. Not strictly necessary right now, but just good to know. Okay, so that's it. We've installed Python and we've got it working and not complaining. That'll be it for now. See you in the next video. Hello, welcome back. Now let's actually get Pygame doing some things. In this video, we're going to be looking at colors. But before we get colors, we need to get a screen. So in Python, well, I like to use all caps for my global variables. We'll make a global variable called screen size. Now screen size will be a tuple, which is a kind of like a list. It's a collection of two numbers. We'll go a width of 300, a height of 600, and that will be our screen size. Okay, awesome. So I'll just like to comment my code. That is good. Okay, the next thing I need is I want to make a screen. So we'll say make a screen, store that in the variable screen. We'll go Pygame. So that was just tab to autocomplete that name there. So what this is doing is this is setting the video mode for Python, and by default that also returns a surface which will be used as the window. Now a surface is a collection of data, and when you write numbers to that data it appears as pixels. Okay, so let's just run this really quickly, and it popped up and it went, and it popped up and it went. So cool, we're creating a surface. The problem is this is a script and it ends as soon as the script ends. So if we want to keep that surface on the screen, we need to define what's called a main loop. Okay, so this loop will go on forever and ever, but we do want to be able to exit out of it. So we need to get an event. We'll go for event. Okay, cool. So we will go more in depth in events in a later video, but basically the event gets a list of all the events which occurred, and it also clears the list so our list of events doesn't back up. And then the quit event happens when someone hits an escape, so or crosses a little, clicks a little cross on the window. So let's run this, and there it is. Our window is there. That's good. Now if we close, it's gone. Do that again. Run it, it's there. We close, it's gone. Let me just make this screen a little bigger. Okay, that might help to see the text. Okay, so what do we want to do now? Well, let's make some colors. So we can make colors any way we want. But I like to search for color palettes because why not? Now any website should be fine. Here we have a bunch of palettes. Okay, so here we have a bunch of palettes, and we can select any of these. For instance, if we are interested in this palette, we can click on it, and it gives us the hexadecimal codes down here. However, Python takes its colors in RGB, red, green, blue codes, which we also have down here. Red, green, blue is Red, green, blue is 8-bit color, which means it's an integer going between 0 and 255, where all zeros is no contribution and 255 is maximum contribution. So black would be 0, 0, 0, white would be 255 in each component. So let's say, maybe not this exact one, but let's say we grab a color palette like this, and we're going to call this palette. And I'm going to define this as a dictionary. A dictionary is a set of key value pairs where we can reference something by a key. So let's say we have 41 in the red, 127 in the green, 135 in the blue, and that's a kind of teal color. So Pygame likes colors in this format, and we can reference them with these names. This is a dictionary. So let's say we want to use this color to fill the screen. So we've done our events. Now we'll start our
draw.
Okay, so we go screen, fill, and then we type in the color that we want to fill with. So we're going to grab the palette and we're going to grab the teal color from in there. Okay, cool. So we hit run and nothing happens. That's okay. Now the reason for that is that Pygame cannot be drawing things to screen at the same time that it is showing a surface. Do you know what I mean? So if we have this set of memory and we write pixels to that memory, we can't do that while it's on the screen. It'll look ugly. So what Pygame does is it separates the drawing from the rendering, if that even makes sense. What we need to do is we need to update the display. Okay, so we run that. And there it is. That works. That's cool. Okay, so the next thing I want to do is I want to make a rectangle which will represent the board. So let's go ahead and do that. But of course we need more colors, so we'll update our palette. Okay, so in order to draw a rectangle, we'll need to use this function rect, which is within the draw module. Now, we have the surface that we're drawing to, the color that we're drawing the rectangle with, and then the next one is the rectangle structure that we're drawing. So we call the rect class from Pygame, and we can see the arguments here. We need the left, top, width, and height of this. Okay, so let's say we're going to go with the left and top is 50 and 50, so close to the top left corner of the screen. The width is 200 pixels, the height is 400 pixels. Okay, so let's run this now. And there we have it. We have our game board where the game will be occurring. Cool. So that'll be it for now. See you in the next video. Hello. In this video, we're going to investigate this event loop, event section, and learn a little bit more about how it works, or how we can learn about how it works. So you may notice I've been calling a few functions out of the blue. If you want to look these up, well, you can always Google them, or you can go to pygame.org and go to docs, and here we can look up any useful documentation that we want. We also have a few tutorials and things. It's really cool. Good website. But here's another method that we can use. So what we've got is here we're looping through the set of events, and we're working with it, well, we can always just print the event and just see what we're getting. So here we can see we have a bunch of events are run at the beginning. For instance, a bunch of audio devices are added. All these things are set up. The video stuff is exposed for rendering and all of this. Awesome. Okay, now we go to the window, and when our mouse is inside the window, we have a mouse motion event. It tells us the position, the relative movement, so how much it moved since the last frame, as well as buttons. Now what buttons means is which buttons are on. So if I click left and then I move, then I've got a mouse movement with mouse button 1, that's a left click. I let go, I have a mouse button up event. I right click, mouse button down, that's button 3 for the right button. And then I've got a 1 in position 3 down here. The center is button 2. And then we can also do these things. So we have, I just clicked S. We have a key down event. It tells us each of these things, each of these values. And we also have a text input event. So that's interesting. So that's cool. So now we can start to use some of these. So now instead of printing the event, we will go, I'll leave that there. Actually, no, I'll comment it out. Okay, now let's go, okay, let's test this. Let's say I want to test for pressing A. Okay, so I look back to that and I say, okay, well, when I was printing out the events, that was a key down event. So let's say, yep, that is within Pygame's library. Cool, so we can use that. And then we want just the A key. Now we could go like if the Unicode equals A, but here's a better way, or a different way. Key is equal to Pygame key A. Then let's just log something out. So let's say print it probably shouldn't be capital A, right? Because it's just, it doesn't matter. It'll work for both. Okay, so let's run this. Go down. I hit A and it says A pressed. I hit A, I'm holding A, but the event is only triggered when the key is pressed down. I release A, I press A again. That's it. Okay, so let's do this again. We'll go, if event type is Pygame key up, and event, yep, okay. That's released. Okay, cool. So let's run this. Now I go A pressed, A released, A pressed, A released. Awesome. Okay, so this is cool, but there's one issue, or it's not an issue, right? It's just a different way of doing things. You might want to not be testing for a key press or release, but to be testing to see if a key is currently being held down. So one way to do that is to track with a variable when a key was pressed and released, but that's a little bit too much work. Let's do this. Let's say, and we'll do this outside of the event loop.
So say keys equals Pygame key
Get pressed. Now what that does, well, I won't say it. Let's find out. Let's print that. So according to the documentation, this is an array which indicates which set of keys is currently pressed at this time. This isn't this isn't very useful, right? It's a whole set of keys. It's a Boolean thing. So let's go. this is basically kind of like a dictionary. So we'll go if keys, and then we're going to access that with Pygame. Let's go for the S key.
PS.
If I can spell. Okay, cool. Cool. So let's run this. A is doing nothing because I commented that out. S, yep. Cool. So that's how events work. And those are two different ways of getting detecting key presses. Okay. So the other thing I want to look at in this video is I want to look at frame rates because that's kind of important. I'll just get rid of this code. Okay, so in order to track frame rates, we will need to create what's called a timer or a clock object. So we'll go this section, we're going to create our objects. Okay, this function returns a new class called a clock, which does our timing for us. Okay, so we've done the update and the draw.
Let's go. Timing.
Okay, one thing we might want to know is what frame rate are we at. So we'll change the caption for the game. We'll go okay, so get FPS returns the frame rate that the game is running at, pretty much, and this str converts it into a string so that we can turn that number into the display window title. Now clock.tick just updates the clock and keeps the timing running smoothly. So let's run this right now, and it says we're running at about 2,500 frames per second. That's a bit too much for our game. So what we can do is, instead of this, we can pass in a number, and this is telling Python which frame rate to cap the clock at. So we want to cap this at 60 frames per second. We run this again, and yes, that's pretty close to 60 frames per second. So that'll be it for now. I'll see you next time. Welcome. In today's video, we are going to start looking at text. Okay, so the first thing we're going to need is to set up a font. We're going to need to select a font. Now, Pygame has a function for this, but what we need to do for the function is we need to supply the name of the font that we want. And to start, we might just want to know what is the whole set of fonts that Pygame will support. As a matter of fact, let's print this out. So we'll go print Pygame. It's in the, whoops, not the Gont, but the font module. And it's get fonts. This returns a list of strings, all the fonts that we support. So let's get that and print that out. Cool. Then we bring up the console. And yeah, there's heaps. There's heaps. Okay, so let's say we pick a few of these and we want to use them. I'm going to create one font for my title and another font for general text. Okay, so we'll create okay, cool. We've got our fonts. Awesome. So then the next thing we need is we need to use them. So let's say that we have the title. The title is created once and it never changes. So we can actually create that as an object. Now, the way this works is we call render, pass in a string of the text that we want. The next argument is whether to anti-alias, that is basically to blur the sides so it doesn't look jagged and bad. So we'll do that. Then we have the color that we want to render in and the background color. Now by default, this background color is none, so by default there's no background. What this does is this returns a surface. You may remember that the screen is a surface, it's a collection of pixels. Well, when we create a text object, it's a surface. It's like an image of the text. So let's call this, we'll say, call this the title object. We grab the font and we render that font. I'm going to call this Sugar Smash. We do want to anti-alias, and for the color, let's make this yellow. Okay, cool. So we've got that. Now we want to render it. So we'll go. Okay, so the fill will fill the whole screen, and then on top of that we want to draw our game board, and then this isn't going to go on top, but it's kind of on the same level. We need to be a little careful about our draw order. We'll go Pygame. Sorry, not that. So what we need to do is we need to blit, because we have one surface which has the text data and another surface which is the screen. That's where we're drawing it. So we'll call, this is the format. We have okay, so we call this on the surface that we want to copy onto, and we pass in the surface that we want to copy onto that surface, and we also pass in the coordinates of the upper left. So let's go, whoops, screen blit title, and I guess we'll go 20 pixels off the left. 10 pixels down. Let's just see how that looks. So we run this, we see our text, but it's a little too low. No problem at all. We can simply adjust. So I think if we set this to -10, this might look good. Yeah, and then maybe, I don't know. This is completely up to you. Maybe shift it over a little bit. It's fine. That's okay, it's acceptable. So we've got our title. Another thing we might want to do, another good use for text, is to display debugging information. So in this case, I'm going to grab the mouse coordinate in every frame, and I'm going to just output where the mouse is, just so I can double check myself. Double check myself before I double wreck myself. Okay, so I'm going to call this in the update section. So we go, the way we get the mouse coordinate is we go Pygame mouse get position, and that passes back the XY coordinates. Okay, and now we're going to make an object called mouse label. Okay, cool. So we've created this mouse label. We see we have a foreground of red, a background of yellow, and we're using an F string, which is a really useful trick to get that information into the string. Okay, cool. So we've blitted the title. Now let's blit the mouse label. And let's go on the left, but then further down. So if we're starting at 50 and we have a height of 400, then we end at 450. Let's put this at a height of 460. Okay. There, cool. So see, we've got a display for the mouse. We're not on the screen right now, but the moment we come on the screen, this updates with the mouse's position. So let's just double check this. I think I mentioned before that 0, 0 is the upper left corner. Let's confirm it. So we go to the left, we have a coordinate close to 0. We go up, and yeah, that's 0, 0 up there. And then down here is the other end. Okay, so that'll be it for now. See you next time. Hello, hi. Let's start putting some images on our screen. Won't be very interesting without images. To start with, just a little note, where can we get images? Well, I like to get a lot of my images from two sources, flaticon.com and opengameart.org. Both of these are really good just for free resources if you want to just prototype something, get something going really quickly. I think what I did for this one is I just searched jewels, and then I grabbed a few of these jewel icons. But let's get to it. So what I did is I grabbed these icons and I put them over here in this graphics folder. We've got each of these gems, there's 5 of them. Let's put those in the game. Okay, so to start with, we're going to create a dictionary for our jewels objects, and we're going to reference them by name. So for instance, the red gem is the first one there. We will load this up, so we'll go Pygame and the image module within Pygame, and we're going to load this in. And I'll just double check. Okay, so we're within graphics, and it's gem.png is the file name for that red jewel. So we load this in, but there's something that's really important. What we need to do is we also need to convert it. What this does is we can load things without converting them, but if we load them without converting them, then they will be in an unoptimal format to blit to the screen, and that means every time the gem is drawn on the screen, there's a little bit of extra overhead, which isn't ideal. So what we'll do instead is we'll convert it, and yeah, let's do that for now. So we'll go ahead and grab all of our gems. There are 5 of them. And these are pretty much what they were called: Gem 1, Gem 2, 3, and 4. Okay, so we've got that. Now let's draw these to the screen. Okay, so let's see. We draw the screen, then we want to draw the board on top of that, and then on top of the board we want to draw our gems. So let's make a variable called jewel top, which is really tracking the y coordinate where the gems will be drawn, and we'll loop through. So we'll say while jewel top plus 40 is less than, we'll go 430, and I'm just going to, now we'll go with this. Okay, so we've got a screen height of 400, starting at y equals 50, so the bottom of our screen board should be 450. What we're doing is we're taking the height at the top of the graphic plus 40. We're going to go 40 either way for the width and height of the images, and then this will tell us where the bottom is. Okay, so while that is true, then we'll go ahead and draw these. We'll go Okay, cool. So that is just a row, and then we will go one layer down. So we'll increase this by 40, and that'll draw the next layer. Okay, let's go ahead and run this, and we have an error. So what is this saying? It's saying no video mode has been set. And we can say, wait a second, but we ran display set mode, didn't we? Didn't we? Well, yes, we did, but we ran it down here before we loaded and converted. So let's go copy paste that and just stick it right up the top. And this should work. Oh yeah, okay, yep, sorry, I wrote glue instead of blue. That is fine, these things happen. Okay, little bit of an issue, and the issue is these backgrounds. No problem. So what we do is, instead of just convert, we have an alpha channel as well. So we call convert alpha. And there it is, more or less. Now we can adjust this a little bit. So see the this ground here. We can probably shorten the board. So let's shorten the board to about 380. And that's gone down by 20 pixels. So we'll decrease this by 20 pixels as well. And there we have it. We have images going. So that'll be it for now. And yeah, see you next time. Hello, hi. In this video, we're going to start doing a bit of object-oriented programming. We're going to make a class to represent a piece of candy. Here, we hard-coded our drawing. Let's not do that. So we'll go up above the object creation and we'll declare a class called candy piece. Okay, so in Python, every class has a constructor which is always called the same thing. It's called this init function, and it always takes in a parameter called self, which is a reference to the instance of the object which is being created. So let's say that we want to create a piece of candy at a given position with a given type. Okay, so we'll first of all set the class's variables to match the parameters. And that's about all we can do with this at the moment. The next thing we'll do is we will draw the object. So we'll make a draw function. And every function for a class, it always takes in a self parameter, but we also want a surface that the object will be drawn to. So what we will do is we will blit onto that surface. So we'll say
split.
Okay, now I found that just adding 4 to both the X and the Y helps to kind of move things along, because these images are 32 by 32. So if we look at the X, that means if we're putting them onto a 40 pixel square, then we need 8 pixels in total either side, which divided by 2 is 4. So we're padding our image. Okay, so that's it. That's the class. Now let's actually use this. So we will create, right now we'll just have it as a list for all the pieces in our game. And we will go start with X of 50, Y of 60, and then we're just going to loop through. So okay, so What I want to do right now is just select a random type. The type parameter will be the string, and I've forgotten to define this, but we can define it right now. Okay, so let's say define a list called types, and that is just this set of strings. Okay, cool. Now the next thing we want to do is we want to select one of these at random. So we're going to need some random function. So we'll go here and we'll go import random. Okay. And then down here, we're going to call rand int because we want an integer. It says here, return random integer in the range AB, including both endpoints. So we have 5 joules, which means we want to be randomly somewhere between 0 and 4. That'll span 5 things. Okay, now we'll go.
Pieces append.
Create a candy piece using the x and y from within the loop and the type variable which was set here. Then what we want to do is this is within the y loop, so we want to increment y plus equals 40, and then we want to increment x at the end of the x loop. But if we run this, oh, of course, because I haven't fixed up my code. Okay, so let's get rid of this, and we'll say loop through all of the candy pieces. So we'll say for piece in pieces. So this loops through all of the candy pieces using piece as a temporary variable, which at each step of the loop is referencing the current iteration within the loop. So we'll go piece draw on the screen. Okay. So run this now, and we've just got a single row. This is not so good. Now the reason for this is that we set this up x at 50, and we go through the full column. So we go down every row, running y up to, just before 430. But then what we need to do is we need to reset y for the start of the next column. So try this again, and there we are. We have a set of things. Okay, so that'll be it for now, and yeah, see you next time. Hello, welcome back. In this video, we are going to create another class to represent the game board onto which the pieces will be put. So we can close this, minimize that now, we'll make another class, and we'll make our initializer. Now, the game board will represent the yellow rectangle which is on the screen right now. In order to make that, we will need to pass in an x and y coordinate at which to create that. So we'll take those variables and bring them in. And we will also set up width and height variables. In this case, I'm going to hard code them. That's perfectly fine for a small project. Okay, now what I'm going to do is I am going to set up a few other variables. So what I really want to do is treat the board as its own surface, because then I can draw the joules onto the board's surface and draw the board's surface onto the screen's surface. Let's try to set up a hierarchy. One benefit to this is if a joule is outside of bounds for the board, it just won't be drawn. So this is good. So we'll create a surface, call it self.surface. The way we do this is we go pygame.draw surface, and it tells us the only thing we really need to pass in is a coordinate for the top left. Sorry, not that. Sorry, I'm going crazy. The only thing we need to pass in is the width and height of the surface that we wish to create. Okay, so we're also going to track how many rows and columns we will create. So we'll go self number of rows is equal to self height over, and we're going to create another variable up above called piece size. Okay, so this is a common source of confusion. When you look at row column notation, the rows are actually vertical. Rows are actually vertical, so they're based on height or y, and columns are actually how far you are horizontally, which is based on x. So for that reason, I'm using this, even though with a matrix, it's common to access them by row first and then column. With Cartesian coordinates, it's common to access them x first and then y, but the order is slightly mixed around. So if we can be good with that, then we can save ourselves a lot of trouble. Okay, what we also need is the board is going to control a bunch of pieces. So we'll create, right now, it'll just be, okay, so we'll create this as a matrix or a two-dimensional list, but we're going to make a function called reset, which will set this up actually as a two-dimensional list. And here's what we'll do. So we'll say, go through all of our rows. This isn't self.reset, it's a function, so we'll go def. Okay, so imagine that we are creating an array with 10 rows. Then we loop through this 10 times, and each time inside our list we put an empty list. Each list represents a row of the array. So then within each row we need to put in a column entry. So we'll say for so we'll access the current row. So we'll go self pieces row, and to that we will append. Well, an entry in this case is a reference. The Python version of null reference is none. We could append 0, that would work just the same way. This is just indicating that the board is empty, nothing is in this place right now. Good, so we'll call this function, we'll go self.reset, and then we'll want a function which puts things in the board, which we will call populate. Okay, so we'll need to generate an x and y for this row and column. So we'll say x is based on the column, so it's the column times piece size, and y is the row. Times piece size. Okay. Okay, so if the surface starts at x equals 50, y equals 50, then it would make sense that we would want to add a displacement amount to our own position. However, I'll show you in a second why that's a little bit off. But let's go ahead and do this. So we'll populate the board, and then we also want a function to draw the board. Okay, so let's have a look at this. So we've made a function where we want to draw our game board, and we tell it which surface we want the game board to be drawn onto. So we do all our drawing stuff, and then in the end we copy our surface, the game board surface, onto the screen surface or the window surface, the parent surface, which was passed in up above. So what we do is we loop through, and this is just a little check because none is the code I'm using to show that a piece is empty. So if it's not empty, then we can draw it, and we draw it onto the game board surface, not the parent surface. Anyway, so let's go ahead and set this up because we've got all of this working pretty well. We'll go to create objects, and now instead of all this code, we can just say board equals game board, and we want to set this up at, I think it was 50 across, 50 down. And now for the draw, instead of this bit, we just want pass in the screen and draw that. Okay, so we'll run this, and notice that it looks a little bit off. So take this piece here, its x coordinate. Okay, so the x coordinate of the board is 50. And then when we created this, we were going through the loop and we had a value of 0. Then we added like 50 and 50 or something like that. Unfortunately, this has just pushed it a little too far, because when we blit these pictures onto this screen, it is based on this game board's local coordinates. So all of this to say, okay, we want to, when we populate it, just use our own local coordinate system. So run this, and there we have it. It's working. Awesome. Yep, so that'll be it. See you in the next one. Hello, how's it going? In this video, we're going to take our program and break it apart into a bunch of separate files, a bunch of modules which all kind of import each other. See, our program is getting to be just one large file, and that's okay for small programs, and 100 lines isn't even that big. However, if we get to 1,000 lines, it's a great practice to break things up. So to start with, we will grab everything. We'll kind of go one step at a time. So we'll grab everything and copy it. Actually, what am I thinking? No, let's start with the classes first. So We'll grab candy piece, we'll make that its own file. So we'll cut that. We'll save it as piece.py. Okay, so note here it's saying, hey, I don't know what joules is. Fair enough. So what we can do is we can grab the set of joules and paste that in. Now we could declare this as a member variable. However, what that would mean is that these images are loaded in for every single candy piece, and that's not very efficient. So what we can do instead is we can declare this, we can declare this at a level of indentation inside the class. This makes it a class variable. Now in order to access it, we access it based on the class name. Okay, so that is working just fine. However, it's now saying, hey, what's Pygame? And that makes sense because we don't have Pygame. So we'll make another file, and I'm going to call this file config or configuration.py. And within this, I'm going to have, let's grab all of this, put that there. And I also want to grab the palette. So basically, config is going to be a common file that a lot of different modules have access to. And that's why I want to put palette in there, because I want both the piece and the game board to have access to the palette. Okay, no problem. So I go here and I say, now I could say, import config, and then down here I'd write something like config.pygame, but that gets a bit annoying. I mean, we're importing modules within modules, and config isn't too big. There's not a chance of a name clash, so for that reason I'm going to say this way, from config import all. And what this does is it's called a wildcard import. It just imports everything, but basically what it does is it almost just copy pastes this code and puts it here without the protection of a module name. And the benefit of that is I don't need to reference this within the module config. The drawback to that is as my libraries get larger and larger and things start to reference other things, it can create a little bit of spaghetti code, but we're going to, it's manageable. Okay, so now we will grab game board and make that its own thing. So grab all of that. Maybe not all at once. Sorry, maybe not. Okay. Make a new file. We'll call that gameboard.py, or even board.py, that's fine. Okay. So, first thing, it's complaining about piece size. So, we can probably declare this as a class variable. So we'll go back to piece size. Okay. Then we need to grab all of the config stuff. So from import everything. Good. Then we need candy piece. So we've got piece, so we'll say import piece. Then down here. Okay, now we need types. So we can probably take types and declare it in here. Okay, awesome. So then the next step is I'm going to create another class to run the game. So I'll make a new file and we'll call this app.py. And I'll pretty much just grab everything here. Yeah, why not? Let's grab everything here and paste it in. And then I'll try to put it within a class. So I'll just do this kind of step down. So we'll say import that. The app will need to know about board stuff. So we'll import
board.
Okay, so the variables that I'm going to grab for the class are pretty much the fonts. Because they don't change. Now we'll go to the initialization. So what do we want? Well, we want the clock and the board.
Okay, and then title.
So you might be saying, okay, awesome, but what is going on? Why are we leaving this screen size and screen down here? So the reason for that is that so Pygame is imported at this point and initialized at this point because there are a bunch of other, for example, piece imports from config, and there's no way to guarantee that piece is going to be imported before the app is created. As a matter of fact, that's probably not going to happen. And remember from a video before, in order to load images, we need the video mode to be set. So for that reason, we are going to take this information and go to config and set it up there. And now screen is going to go from a local variable to a full-on global variable. That is perfectly fine. Okay. So now we've got this. This is fine, 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 fine. Okay, so now we've got the main loop. One way to do a main loop is to instead of putting a while loop in the main loop here will be a function which will be called repeatedly, and at the end of each run it will return whether the game should end or not. So I'll just grab all of this code and I will, that is control square bracket to move things. So if I want to indent this to the left, it's control left square bracket, control right square bracket. Okay, so if we exit, then we want to return false because we're telling the program to quit. And we probably don't need this. Mouse get position, yeah, that's fine. Mouse label, that's fine. But we're going to need to go app, and then this will be
screen.
And we actually don't need this because the board creates that yellow thing by itself. Okay, cool. So that is running. And then at the end of this, we want to return true because we're indicating to whatever called this that we want the program to keep running. So we're almost done. That was a lot of fun. Now we'll go to the main and we'll code this up. First of all, we'll need to create an app. So we'll import app. And then this is just a fancy way to tell Python this is the main entry point. It's an internal variable called name, and if it's equal to main, then the program is at its entry point. Kind of like how C has a main function always as the entry point for the beginning. So we'll create a game app. And then we'll set this up. We'll say running. Cool. Okay, so that has just kind of abstracted the while loop out of the app. And this is just one pattern. This is just one way to get things running. So let's try this. Ooh, that's not good. Okay. Board has no attribute draw. Of course, because we need self.board. By the way, my debugging technique is kind of bumper cut. I just do something and I see what the feedback is from the IDE, and then there's nothing wrong with that. It works. Okay, so here we have it. Is good. It works. We can exit. It works. We can go back in. Another point is if I go to, before I could just run it from anywhere and it would run, but now if I go to board.py, it doesn't run, which is confusing because it looks like it almost runs, right? Because it creates a window. But what happens is this board.py, all it does is declares a class. It does nothing. The window is opening because when we import config, inside there, we're setting up the video mode. So it's creating a window. But the main entry point is here. We always need to run this program. Okay, so that'll be it for now. Yeah, hope you're enjoying this course, and yeah, see you in the next video. Hello, hi. In this video, we're going to start working with some mouse events, specifically mouse movement and mouse clicking. Now, I'll just give you an idea of what we want. We want to move the mouse and highlight whichever piece of candy is under the mouse. And then when we click on a piece, we want to highlight all of the pieces which are neighbors. So, and also beyond that, we also want to, what am I thinking? We want to highlight which pieces are neighbors, and if we click on a neighbor, swap the pieces around. So I'm going to design this starting from the basic component and going back to the large system. Starting with the piece, the candy piece. We're going to add a few more variables here. So first of all, we're going to track whether the mouse is hovering over the piece. And then we're going to track whether the piece is, track whether the piece is the neighbor of another piece, which is being clicked on. Okay, now these are pretty simple fields, and we could get away with not using getters and setters I'm going to kind of do that, but I am going to create some setters for this. Okay. Okay, cool. So, cool, that is looking good. The next thing I want to do is, in order to tell whether things are connected or not, it's useful to be able to get the Cartesian coordinates, that's the x, y coordinates of an object. So we'll go def. If I could spell. Okay, cool. So for each piece, we also want to be able to get its XY coordinates. And finally, for the piece class, I'm going to be drawing a rectangle underneath the triangle, basically to indicate whether it is highlighted or etc. So whether it's highlighted or a neighbor of a highlighted piece. So I'm going to make a variable called color. So we've got that, but, so we'll just go for it. So we'll say if we are the neighbor of a highlighted piece, and also the mouse is hovering over us, so the player has clicked on a piece, and we're the neighbor of that, and they're about to click on us, then we want to display the box in a slightly different color. In this case, we'll change that color to red. Okay, now what are the two cases where we want to highlight the piece in some sense? It's either if we are a neighbor or if the mouse is hovering over us. So we'll say if self.neighbor or self.mouse hover. In both of those cases, we want to draw a rectangle underneath our piece. So we'll say
Pygame, draw. What's going on here?
Okay, so what I want to do is I want the candy piece to know how big a piece should be. Okay, fair enough. However, before, when I abstracted this out, I put piece size in the board. So now instead of that, we're going to take that out and we will declare it as a global variable, because it turns out that both the board and the candy needs to know about piece size. Okay. So now everywhere here, that's just piece size. So refactoring is good. Refactor early, refactor often. I think that's okay. Now, this should still work just the same, just with no highlighting. So I run this now. Yep, it all works. Awesome. Okay. So now what do I want to do? Well, let's look at the board. Okay. So now the board is going to be reacting to the mouse. So first of all, we'll make a function to determine whether the board has the mouse within its bounds. So we'll make this has mouse. We can actually just change that around. We don't need to pass that in because we know how to get this. Actually, no, I changed my mind because we might want to call like get the mouse position earlier. So this is fine. Okay, so we want the mouse's X position to be bigger than our position, and also we want its X position to be less than our X position plus our width. So if it's to the right of our left side and it's to the left of our right side, that is the X check variable, and it's pretty much going to be the same for Y. And I could write this all in one line, there's nothing wrong with that. This is just, it neatens the code a little bit. Okay, so if both of those pass, then that's what we're after. So we're going to return check and I check. Okay, cool. Okay, so let's see. Let's make a function called handle mouse movement. First thing we'll do is we'll get the mouse position. And then we'll check if that is within our bounds. And then if it is within our bounds, then what we want to do is get the mouse XY coordinates, convert it into grid coordinates, row and column. So then we'll make another function called Cartesian to grid. And this takes in an XY coordinate. And we'll say, okay, row is, we'll go with this, we'll go Y minus, so again, it's really important to remember that Cartesian coordinates go X and then Y, whereas grid coordinates go row and column, where row is really the Y coordinate and column is really the X coordinate. It's a little bit tricky. Now I'm just going to leave this right now, just to kind of test that the Cartesian to grid thing is working. So what I'll do is, let's set up the app so that it is displaying the so it's displaying the row and column that we are in. So we'll say, go to the main loop, and we will say if
self-board has mouse.
We can just pass in the XY that we've got here because that is the mouse position. Then we'll make a variable. And what I want to do with this is I want to create a label. The label needs some text. So if the board does not have the mouse, we'll just set the row and column to -1 each. That'll be our sentinel value to show that the board doesn't have the mouse. Okay, cool. So now here we've got the mouse label. Doesn't really matter where we put this, but I want to put the labels kind of near the same spot. So we've got mouse, oops. Okay, we've got mouse label. Now I'll call this the grid label. Good. and then we will blit that down below. Got them, yep, mouse label, and we'll go grid label, and that position is fine. We'll just put it a little bit lower, so like 480 or something. Okay, cool. Let's run this and see if this is working. Okay, so we go up, and it says we are in row 0, column 0. Awesome. As we go to the right, the columns are increasing. That's good. That's really good. Yeah, that's fine. And then as we go down here, the rows are increasing. There's just, if we go down here, see, we're fitting 9 of these down, so we should be going down to 8. But then if we go a little bit lower, it goes to 9. And I think, no, the columns are okay. But let's just fix this up. So let's go to the board, and we'll take these results and we will min-max them. So we'll say, what do we want? If we get a value which goes above the number of rows, we'll go self num rows, but then we want that it to be, you know, -1, because like if we've got 9 rows, then we want to go to row 8 because it goes from 0 to 8. And similarly, we'll clamp that just in case it goes below 0 for some reason. It should never do that, but this is a common pattern. This is a common pattern in like kind of error avoidance. Okay, cool. So that should be working. Now let's go ahead and use that to update our pieces. So down here I said pass, but let's continue on this. So we'll take the row and the column, which the mouse is over. And then we will update that thing. So we'll go self pieces based on this. Okay, cool. Cool. So now we want to set this with a proper update function. So we'll create a function up here called update. And the first thing we want to do is we want to reset everything. So I'll say set of pieces. Okay, so I grab the current piece and just error checking. I want to make sure it's not empty. So I also want to say, okay, if this piece is not none. Okay, so what this is doing is at the start of the frame, we reset everything, reset the state, and then we do our searches and we add that state back in, and then when we draw it, it draws based on the state. There are other ways to do this, but they kind of involve code which can get a little more confusing. There's too many parts, and it's not worth trying to save performance on this part. It's fine. Okay, so let's go to the app, and we've got our update stage. So we'll go update the board, and then we'll go handle the mouse movement, and then fingers crossed. That's cool. Okay, so if the mouse is not on the board, that's fine. If the mouse is on the board, it highlights the thing. Cool. Now I want to set it up so that I can click on the pieces. So in order to do that, I'll need another function called handle mouse click. Okay, so what I could do is I could get the position of the click and then I could test if, yeah, why not? Why not? I have this thing.
Okay.
So what I want to do is I want to keep track of my selected piece. So I'll go up to the top. Okay, so this is the piece which is currently selected. So what do we have? Okay, so in the case where we click and we don't have a selected piece, then what we're doing is nothing is highlighted and we're selecting a new piece. That's no problem. What we can then do is, if that's not the case, then we are clicking on a piece and we want to try to swap things. So now I'm going to need to write a new function because what we want, well, what I want is I want a function which will tell me the neighbors of a given piece. So I'll create that here. I'm going to call that get neighbors. So we give it a given piece of candy and it searches for the neighbors. Okay, so we could grab, the piece to the left, to the right, above and below, and add those to the set of neighbors. However, that might cause us to go out of bounds. So what I'm going to do is we're going to test the row and column stage by stage. So first of all, we want to get the piece above, we want our row number to be larger than 0. But then if we look at this, there's another thing we should probably check. And we should check if this thing is none, if the piece is empty. Okay, cool. Now let's just keep going with this. So we've got the one above. Now we'll go the piece below. Now to go to the piece below, we're going to be going to row +1, which means we want our row number to be less than our last row number, which is our number of rows minus 1 is our last row. Let me just double check this. That is looking good. And I just realized something. I can grab this code, and instead of pasting this in again, I can just go this piece. Okay, it's looking good. Okay, so column is bigger than 0. That means we're taking on the left. Now we take on the right, so column has to be less than our rightmost column. Okay, that looks good. So this is setting up the bunch of neighbors around a given point.
Okay.
So why do we need this? Well, we want to test if the new piece that we're clicking on in the next frame is one of the neighbors, because we can only swap a piece with its neighbors. If that is in okay, so then this is a valid click. Sorry, my camera just reset. Okay, so now we swap the pieces. So what we can do is we can now this is what I said about not using getters and setters. It's a little quicker in this case, and it is perfectly readable. Okay, so this is a perfectly valid click. The types are changed, so the jewels switch around, and then the selection is gone, so the currently selected piece is set to none. If we click on something which isn't a neighbor of the currently selected piece, then we can't swap, but we might want to set it so that we then focus around that piece. That's probably fine. All right, so what do we need to do? Well, first of all, okay, just double checking. Okay, so what do we need to do? Well, first of all, I've done a lot of talking. Let's actually demonstrate this. We need to go to the update function, and then, so we've reset things. Now let's do self handle mouse movement.
And then
Right. So again, if a piece has been clicked, then we want it to always glow up as if the mouse is always over it. And also we want to set the state of all of that piece's neighbors. As well as handle mouse movement, we'll set the hovering for the pieces. So now we can go to the app and we can get rid of that handle mouse movement. That's handled there. We just need to go here and put in a click event. So we'll say if event type is Pygame, mouse button down, then handle mouse click. And then fingers crossed that should handle it. Let's try that out. Okay, so we click. That's not great. Okay. Non-type object is not iterable. Great. What have I done? Get neighbors. Neighbors is 0. We're appending to neighbors. And then, of course, we need to return neighbors. Okay, let's try that. That's not great. Okay, what have I done here? Maybe this is it. Okay. How did I miss that? Okay, so when we do this, we need to add the... Okay, because before when we were using the mouse, we were using the global coordinate system. These pieces use a local coordinate system, so to get that into global coordinates, we need to add the cameras... Sorry, not the cameras, add the board's offset. And then fingers crossed. Nice. Okay, so we click this and we can hover over other pieces. When we hover over, like we're about to click, then those bits go red and we can click and things swap over and everything resets. So click, click. If I click one and then I click something which is out of bounds, then it just resets. Okay, so that'll be it for now. Have fun and I'll see you next time. All right, bye. Hello, welcome. In this video, we're going to do another algorithm, and this algorithm is to search the pieces, find the sets of pieces which match up in streaks of more than 3, and then eliminate them so we can get things paired up in eliminating and then dropping down. So this is going to be a bit of work. Fair bit of work, but we're going to start with the, again, we'll go component by component. So we'll start with the piece, the candy piece, and we will make a few variables. We'll make a variable to track the, some variables to track the state of a piece, so a piece can be stable or falling. And if it falls, the class has an amount of gravity and a bounce amount. So the bounce amount is, let's go with 0.5. Bounce amount is how much energy is retained when an object bounces. So it comes down with the speed, it bounces. In this case, it's going to keep about 50% of its energy, which will make it gradually go down to nothing. Okay, so then we'll go to the creation stuff. Okay, we'll create a variable called ground y, which is the ground level that we want our piece to sit on, and we'll start that off at the initial y value, and we'll have a velocity that it's falling with, which should start at 0 because the pieces shouldn't be falling at the start. Oops, sorry. Mouse hover is already there, but we do need 2 more variables. Going to track whether a piece has been smashed and piece's state. Okay, cool. So now we'll create, what do we have? We have set mouse hover, set neighbor. Let's create a set smashed. And we'll also do a set ground y. Okay, at this point where we set the ground y, we can also change the state to start falling. So we can say if self.y is less than self.
Ground y. Equals.
Okay, Cool. So then I'm also going to create a function to indicate whether a piece is stable, right? So it falls and then it might hit the ground and bounce and then stabilize. But I want to set it up so that the board only updates once every piece is stable. So I'll need to be able to check that. So I'll go self is stable. Okay, cool. So we've just got one more function that we're going to make, and that is the update function, because now pieces are going to be a little more dynamic. For one thing, this update function will be called by the board, so perhaps we should put the piece in charge of resetting itself. So what did I have before? I set the mouse hover to false, and what was it? Set, not that, set neighbor, that was it. Okay, set neighbor to false. And then I'll proceed with the physics calculations. So we'll say if we're falling, right, so what do we do? First, we increase our velocity, and then we increase our position based on the velocity. No, not candy piece, it's self-velocity. I'm getting tired. Okay, so what do we do then? Well, we might want to bounce. What does bouncing mean? Bouncing, let's say we go past our base level by a big enough amount. Then we bounce up a little bit, then we'll go down a little bit less, and eventually we'll go past our ground level, but we'll be within tolerance, and that will be the end of the bounce. So what do we want to say? We want to say if we are higher than our ground level, in other words, we are below our ground level, and also the absolute value of that difference, so how far we're below ground level. If that is bigger than, and you can tweak these parameters any way you like. Let's go 2 pixels, I guess. So if we overshoot by more than 2 pixels, that's enough energy to bounce us. What does this mean? This means our velocity is multiplied by bounce amount. And we multiply by the negative of that in order to change our direction. Okay, now what do we want to check? Otherwise, if okay, so the reason I'm checking the same condition again is because if this fails, well, it could fail for 1 or 2 reasons. We could be below ground level by a small amount, that's what we're testing here, or we could just be above ground level. So we need to be explicit with this elif. So what do we have? Well, this is when we hit the ground. So our state goes to stable. Our velocity goes to 0. And then just to keep everything on the level, our y is set to the ground level. Okay, so this is all good. I just remembered there's one more thing I want to check. We can add a shaking action to the board when destructions happen. So the horizontal variation will be the object bouncing. Vertical variation will be the bounce. Horizontal variation will be the board exploding when pieces are smashed. So let's set this up so that we're also taking an X offset amount, and not much happens. We just want to also add that X offset to the draw. Okay, so now let's go to the board. Let's close some of these things. Oh, no, actually, I'll set a few things. So the board can similarly be either in a stable state or in a shaking state. So we'll declare those states. Width, surface, that's fine. Pieces, selected piece, reset. Okay. So I'm going to change these reset and populate things. So when we reset, I'm going to hand in the name of the thing that the handle to the set that we're resetting. And then what are we going to do? So we call reset on a general board object. So I'll only do this if the board has no rows in it. In other words, if it's a completely empty board, then we'll set up a new blank board. Otherwise, I'll take an existing board and instead of appending stuff, I'll just set all the entries to none. Because what I'm going to be doing is when I search, I'm going to be recreating the board. Good. So if I get in a board which is non-zero, then I reset everything. Okay. So I'm also going to change this populate. So what we're going to do is we're going to populate a board, but we might want to populate it with copies of another board. So what are we going to do? We're going to loop through, and then if we didn't pass in a board to copy, then we're just going to create a bunch of new pieces. Sorry, I'm going to have to change this. So we're going to go board append. Down there, that's good. Okay, so now here, if we're not copying off a board, then we'll just create a bunch of new pieces. Otherwise, we will just take the corresponding entry from the board that we're copying. Okay, cool. So we've set that up. Okay, so we're going to reset our pieces. We're going to populate our pieces. That is good. Now we need to set a few more things. We need to set the state of our board. Yep, it's currently stable. I'm going to have a parameter to describe the vibrations called time or t, and it's going to be associated with shaking. We're going to set that to 0 to start with, and we're going to have an X offset as well, which corresponds to the shaking. Okay. Okay, so we're going to go update this piece, and there's another thing I'm going to go and do. that is, in the update, we're also going to set our smashed variable to false. It shouldn't be a big deal because we're going to be cleaning up smashed pieces every frame anyway, but this is just to make sure. Okay. Let me handle the mouse movement. Good. Okay. Now what we're going to do is we're going to test. Okay, so I'm going to need to create a few more functions. One is just to test if the game board is stable. So we'll go def.
Okay, so go,
Going to separate this with brackets. Okay, so it seems like this function would be kind of a no-brainer and we wouldn't need a function, right? Because we've got a state. It's pretty easy to check if that is stable, but there are two conditions. The board is stable and all the pieces are stable. That means they're not bouncing. Just to be sure, I'm going to set this up to handle both cases. Okay, so we've got that, but now we'll make another function. So if it's stable, then we go ahead and do our searching stuff. If it's not stable, then we shake the board. So we'll make a shake function, and it's nothing too crazy. I'm just going to use a sign function. So I'll need to import math to get that. Import math. Yeah, now a sign function just pretty much vibrates, goes up and down. It's periodic. I've lost myself. Okay, so we'll go, I don't know, maybe 32 times math sign. And the argument for math sign, the angle will be shake t amount. But I'm going to square it so that as time goes on, the vibrations get faster. It's kind of like whatever. Okay, so we have that, but then we want the amplitude of the vibrations to die down, so then we need to divide by the time as well. But we also need to add 1 to that just to make sure we're never dividing by 0. Okay, so then we want to increment that amount. We'll go bigger than, okay, so the period for sine is 2 pi, so if I go 10 pi, that will be 5 vibrations, maybe more than that because of squaring the frequency, but that's fine. In other words, we'll just let the shake go on for a little bit and then we'll set it back to stable. So we'll go self state is game board stable. We'll set the shake parameter down to 0 again, and we'll set our offset back to 0. Okay, cool. So then let's just change the drawing function. We don't need to do much. We just go down to draw the piece, and we also pass in the vibration of the board, and that should be fine. And we don't need to worry about how the vibration of the board affects the coordinate searching, because we're not going to be running any search functions until the board is completely stable. Okay, so I've put this off long enough. Let's go to the scary searching functions. As with any algorithm, it's good if we break it down into parts. So let's start with, I'm just up here. Okay, let's make a function called, this is all fine.
Yep, that's all fine.
Okay, let's make a function called expand search. Now what this does is it takes a, where did that go? Sorry. It takes a piece, and based on the type that the piece has, it looks at all the neighbors and it grabs all the neighbors which are the same type and sticks them in a list and returns that, because we want to be able to detect when things are stuck together. So we'll go so result will be the list of like pieces. We'll grab the set of nearby pieces. And then what we're doing is we're testing if the types are the same. Okay, cool. So that's it. That's searching done, right? I wish. So this is kind of the expansion step, and we need a basic search function to drive that expansion. So we'll just call that search, and we'll loop through this. So we'll go our search needs to start somewhere. Okay, so you may note that this will kind of involve pieces being searched more than once. It's okay, because all we're doing in this search function is we're kind of flagging pieces for deletion. After we do this, we'll make another function called clean, which deletes things. And the worst that search can do is flag a piece like twice, and that doesn't make a difference. So now we're going to set things up. So we'll have a list of objects which have been searched, and we reset this for every piece. And then we start, oops. So streak is the list of everything which matches with that. We'll start with, well, the first piece. Then we'll create a queue. So we could create a list of objects to search, but what we're going to do is we're going to be looping through that list and removing things from it and adding things to it. And the most efficient data structure for that is a queue. So we'll go up here and we'll import queue. Okay, so I'll put that on. Okay. Okay, so what we've got is we've got our queue, we stick on an item, and then we just keep working with that queue until we've got nothing left to search. Okay, so first of all, we'll pop an item from the queue. And then we will take that item, expand it with the search thing. And we'll take that item which we used to expand the search and stick it on the list of already searched things. Okay, now we're going to look through everything we get. Oops, everything we get in our matches. And we'll only go with things which haven't already been expanded, searched. Okay, we'll set that. And we'll also, so we'll put it onto the queue for things that we want to search in the future. And at the same time, we will append it to the collection of things, the streak. Are we on a streak? How much are we? How much is our streak increasing? Okay, so now at this point, all of the searching has been done. So we say if the length of things on our streak is bigger than 3, then start shaking the board because we're destroying some pieces.
And
okay, so just to check that this is working, what I want to do, well, how can it work? We haven't put it in the update. So we'll go to the update function. So if our board is stable, then search for things that we can destroy, and just do that right now. Oh, also, okay, that looks good. So I just want to, let's go to piece and okay, so I'm going to update these conditions. So I'm going to say, okay, this is a case where we can be red, or if yeah, or if we've been smashed, then we want to indicate that as well. And then down here, this is another case that we're interested in. Okay. So we're not going to delete anything just yet. We're just going to flag things. Okay, so fingers crossed. That's not good. Right, okay. So note down here it says module piece has no attribute is stable. So note that I've been very careful not to directly use the word piece. I've been using this piece or that piece or whatever, because, where is this? Line 84. Because when we call piece, it might, depending on the context, if it's piece as a local variable or function parameter, that's fine. But if it's just on itself, it might look at the module instead of, it shouldn't even, yeah, it should be this piece. Okay, enough talking, let's go. Okay, so if I put this one here, that's not good. Yeah, that's fine, that's fine. It's just not very nice to look at. So I'm just going to comment this out for the moment. Okay. Oh, why are you doing that? Oh, never mind. Point is, it is working. It should be working. Let me go back to the ugly version. So we can see that, yep, there's a connection of 4, and that connection should be deleted. Okay, so let's make a function to clean up the board. Okay, so the first thing I'm going to do is I'm just going to delete every single thing. Every single thing which should be deleted. Okay, so what this does is it basically deletes everything which has been smashed. Next, what I want to do is I want to move things down. Perhaps to start with, let's just run this and go self.search and then clean. Yep. So what is that? 117. So we're just checking. This is just a simple check in case the mouse goes over a piece which is empty. Okay, let's try that again. Okay, cool. It settles down, and then we see some pieces have been deleted. So let's delete some more pieces. So swap these ones, and then, yeah, that seems to work just fine. Okay, now let's drop these pieces down. In order to drop the pieces down, we're going to take a snapshot of the board as it is right now, and then based on the snapshot of the board, we're going to create a new board where all the pieces are moved down. This is why I modified those creation functions before. So what do we have? Okay, so we need to take a snapshot of the board. Okay, so we set this board up to receive pieces. We copy our current pieces into the board, and also we blank out everything that we had before. Okay, now we go ahead and search. So this is a little bit tricky. We'll say check how far each piece must move down. Okay, so now normally we would loop on the row first and then the column. It normally doesn't make a difference, but now we want to vertically scan each column because gravity goes down. So we start with the column. We say for Okay, so we're on a column and then we drop down the rows. And every time we take, or first of all, let's reset the drop, make a variable called drop count. Set that to 0. And then we'll make something called row below. So we're at a piece, we want to check scan below that piece. Then we go down to the next piece, we want to scan below that piece. So we'll say so what this is doing is it's dropping down, but it's dropping down starting at the current row. It doesn't matter if there's nothing in the current position, that's still fine. So now what we're going to do is we'll say send these to new position. Okay, but of course, obviously we can't be searching a board and updating a board at the same time, which is why we have old board just tracks things as they are right now, and then the current pieces is where those pieces are put. Does that even make sense? It might make more sense if we just code it up. So we'll say so this is what we do. We take our current Y position and then we add the number that we need to drop down times how far each drop is. And then we need to put that into the row plus the number of down movements. So we take a piece and we find that there were like 3 empty columns down below. So we take that piece, shift it down 3 rows into our array of pieces. But it still stays in the same column. And then while we're at it, we set the ground level to a little bit lower. Okay, fingers crossed. So I guess let's just try it. That's not good. Must be integers or slices, not floats. Okay, so 165. That's not, it's okay, it happens. 165, so what it's doing, okay, so it's getting this from get self Cartesian to grid. So let's go to whoops, I accidentally did all of this cleaning code in the wrong function. So make sure you're checking that. It's, okay. So we've done that there. We'll put that code there. Yeah, that's fine. Okay. Where did this go? Cartesian to grid. Okay. Now we just want to take this part and convert that to an integer, because if a piece moves, then its x and y will no longer be a whole number. We just cast that back to an integer, and then we try that. That's cool. It's being a little strange here, so we'll have to double check that. That's weird. Let's just double check that. Okay, sorry. After like 20 minutes of meticulously error checking, here's what I found. If we set the bounce amount to 0.5, then in some cases, in this case it's fine, in some cases pieces won't be able to rebound enough to overcome gravity. So what we do is we set this to 0.75 and it works. And now we've got it working. Okay, so that's it for now. Where we're at is we are cleaning up the pieces. That board is refreshing. What we need to do next time is create new pieces. Okay, so that'll be it for now. Hope you had fun. See you soon. Bye. Hello, welcome. Last video was kind of intense, hey? Well, the good news is we are getting to the tip of the hump. We've got one more video to go, one more algorithm, and then it's pretty much done. It's downhill. Speaking of downhill, the next thing we want to do is we need to put in new pieces, which will fall down. So let's do this in the clean function that we made before. So we go kind of condense this down, update, search, expand, clean. Okay, so we've done this. We've sent the old pieces to the new position. The next thing I want to do is I want to fill the gaps. So the number of things that we're going to put in depends on the number of gaps that there were in the column. But we need to keep a track of this. So we'll get the number of column gaps, and then what do we have here? We go through, we get the number of drops, and then the total number of pieces that we want to put in is equal to the maximum of all the drop counts. So we'll say column gaps is equal to the maximum, whichever is larger, either the current number of column gaps or the number of drops which have been calculated on the latest piece, if that makes sense. Okay. So now we're going to use the number of column gaps to determine how many new pieces to create. So X and Y as normal. The only difference is we want to create these pieces shifted up, and then they're going to fall down into place. So we then subtract the, we go column gaps times piece size. That is the number of units we're going to shift them up, and then they're going to fall down into place. Okay. We need to give them a target Y as well, which will pretty much just be this bit here. So now let's talk about creation. We created pieces randomly, and that's okay, but it would be better if we had an algorithm to determine which types were allowed, basically. So let's go and create that. We'll make a function called allowable types, and it will pretty much be the search function again. That's not good. So we'll call this So what we're going to do is we're going to loop through all the pieces. Sorry, not all the pieces. We want to get the allowable types for a given row and column. So at that piece on the board, we're going to loop through all the possible types. And if we don't have a streak, then they're allowed, and we can stick them onto our result thing. So what we want to do is we want to go okay, loop through all our types. So what we're basically going to do is we're going to create an imaginary piece. Well, we're going to create a new piece just for searching purposes. We're not going to add it to the board or anything. Yep, so first piece, we'll just create a piece. And we don't need to do this test. I mean, we created it. We know it's not none. Okay, so we go through with the search. Just double checking. Okay, good. All right, so we start with nothing. We add on the first piece. We go with the queue that we're searching. This all looks pretty good. Yeah, this is fine. This is fine. It's just this bit here. So what we want to do is we want to say, okay, bigger than 3 is the criteria for destroying things. So the opposite of that is less than or equal to 3. That's the criteria for not destroying things. So in that case, we append it to our results. Good. Okay. So now we can incorporate this in our creation code. So we go down to where we're creating a new object. Okay, because we want to work out our types, so we'll say allowable types equals okay, cool. So let's say we have got 3 types which are allowable. Well, then our index should be somewhere between 0 and 2. So we, just pick this at random, and then we go ahead and create the piece. So we say this piece is cool. Okay, so that looks good. Let's grab this while we're at it and put this into the population code. So we go down to populate. Here, instead of just picking one at random, we will okay, and this might not be perfect, but hopefully this will reduce that random, like, create a board and then everything gets destroyed sort of thing. So we'll give that a shot. Good, it's not being destroyed. And then we destroy something. And there are some chains of destruction because the algorithm is just running on new pieces which are coming in. There's no guarantee that we're not going to fall down and create a streak, but it is a little bit more stable. And it's fine, like it's satisfying setting up these chains, but it's just not very interesting if we're suddenly destroying everything at the beginning. You might spend like 30 seconds just watching the screen destroy and reset, destroy and reset. It's not a lot of fun. Anyway, so I mean, that was all I wanted to do for this. Like I said, we are getting to the end of it. Yeah, see you in the next one. Hope you had fun. Hello, how's it going? So in this video, we're going to add score to our game. Bunch of different ways we can do it. Here's how I'm going to do it. So we have an app, and an app keeps repeatedly calling main loop. So let's set it up so that main loop returns the update function from the board returns a score increase. So we'll go to update and we'll say score increase is 0. So each frame, how many points are we adding? Okay, fair enough. So let's keep it simple. We'll get a point every time we destroy a piece. So that destruction happens in the clean function. So we'll say increase it by that amount. So we go down to self.clean, and then here okay, so at this point here we are destroying an object, so we will increment our point count. Then that gets returned at the bottom. Let's double check. Yep, that's fine. Okay, so now let's use this. So we'll go to the app. And the app has a bunch of things. Set the score to 0 initially. And then in the main loop, update the board. We'll increase that amount. Let's also make, let's get rid of this stuff, mouse label, grid label. Instead of that, we will call score label. Why not? Yeah, that's fine. That's fine. Why not? And then we're not going to split that. Let's keep the... Oh, no, that's okay. Talking to myself. Okay, so we will split the score label down there. Let's go. Let's see if it works. So run it right now. We got 0 points, and we do a match. Now we've got 4 points. Now we've smashed another 4. Smashed another 4. Yeah, there it is. Smashed 5. That's it. Simple as that. Cool. So like I said, we're getting to the end of it. Have fun. I'll see you in the next video. Okay, so let's create a new game button. To start with, we will need a new class or a new file. Call it button.py, and we'll go ahead and code this up. This is going to use
a few things.
Okay, so let's create a font for the button, and we can pretty much grab the font from the app, except we'll change it up a little bit. We'll change the size of the font, so we'll make it 24, that's fine. Okay. Ooh. Okay, so what do we want? Well, to make a button, we want to define it with a rectangle, give it a string of text, and also give it an on color and an off color. Most of these can straight up be dialed in. Okay, done. That's initialization. Then we need to check if the thing has the mouse. So no problem. We can borrow that from. We can borrow that from here. And let's create a version which doesn't have that. Then we need to be able to handle mouse movement. Oh, another thing I forgot. We'll have a color which this thing is displayed with, and by default we'll set that to the off color. Okay, fair enough. Then we need a handle mouse movement.
Okay. So we've got the mouse.
Okay, cool. Now we'll handle mouse click. And this is actually, it's not too bad, right? Because all the new game button does is makes a new game. So all the app needs to know is when we click, did we click inside the new game button? So all we need to do is return whether we had the mouse at that point in time. Done. Okay. Now we'll draw the object. Works pretty similar to before. So we'll make a... So I'll render that font. And we're rendering this every frame, so we could dynamically be changing the text. Nothing wrong with that. So the foreground, or the text color is red, and self.color is the background color. Okay, cool. So then we just split that to the surface. Cool, so that's it. Our button is there. So then the question is, how do we use this? Well, it might be helpful to look at the main function. Actually, I'll go back to the app and I'll define a few things. So we've got this. Let's define some, these are basically enums in disguise. So what can the app do at the end of a loop? It can continue, it can create a new game, or it can exit. Okay, so then we go back to main, and instead of running, we'll call this result, and that will be equal to the continue flag. And then our test is this is the result equal to continue. And while that is, then we go ahead and we run the main loop. Then we test if the result is equal to inside the app module, the app class, new game, then that's actually no problem. All we need to do
is
create a new instance. Because Python is a garbage collected library, it looks at this and it says, okay, no problem. This old app here, there's nothing referring to that object anymore when the reference is overwritten, and so that object is destroyed by Java's garbage collector. So we're all good on that front. All we need to do now is set that flag again, and that will keep things going. Okay, so now to the app. We go to create objects. We'll say self.newGame button. And in order to do this, we will need to import button. Okay. So this is within the button module, the button class. And what do we want to do? Pass in a rectangle, which X position is 100, Y position is 500, and it is 100 pixels wide, 50 deep. Okay, the text we're going to put there is new game. The on color yeah, let me just double check. It's light with a hyphen, right? Yep, okay, cool. Cool, and then the off color is just the yellow. Okay. All good. Cool, so then within the main loop, what do we want to do? If we are okay, so we want to know a click has occurred with the left mouse button. Let's go call the mouse click function, and if that's true, then this variable clicked will be true. In that case, we want to start a new game. So if that's true, then we return the new game flag. Otherwise, just continue as normal. We can get rid of this. We don't need that. But what? Should just double check. Yeah, no, that's definitely fine. Oh, it's down here. Okay. Mouse. Okay, and then we go to draw. So draw the new game button, and we're going to pass it in the screen as the surface that we're drawing to. Okay, fingers crossed. We run this. Doesn't work. Okay. Right. No problem. So I just checked this. It says our button has no attribute X. Yes. Okay. So what we need is rectangle X, and then rectangle W is Pygame's abbreviation for rectangle width, and then rectangle Y and rectangle H for height. Okay, let's try that again. That's not good, because we need to return something. Okay, so So we do all of this, and we don't return true, we return app continue. So I think because new game was defined as 1, when we return true, is automatically saying make a new game all the time. And then what else do we have? If event type is Pygame quit, then return app exit. Okay, let's try this again. Cool. What was that I said before about like my method for debugging is just like bumper cart, make a mistake and learn from it, or don't. Okay, so we can highlight the button. When we click it, we've got a new game because everything's reset. As a matter of fact, we can get some points and then reset it. Our points go to 0. Awesome, so that's the new game button. Hope you had fun. I'll see you in the next one. Hello, how's it going? Last video, last session. So I just want to touch a little bit on audio. Pygame has its own audio modules, but they're a little bit hit and miss when it comes to loading things. So I've just got a few sound effects. We've got a click and a smash for smashing jewels and stuff, and I want to load them. So I would recommend looking into OpenAL. There's a library here, PyOpenAL, which is pretty good. As you can see here, we just need to call pip install PyOpenAL, just like we did with Pygame. And there's a note here that you also need. It says a shared OpenAL library, which, yeah, I think by default Windows should have it. If it doesn't, you can just click any of these links and download that. Yes. Okay. So as we can see here, we have some examples. We import everything from OpenAL. This is not necessary, it's just for the example. Open up a sound source, play it. We can check if it's playing or not, and we can call quit. So let's put that together. Okay, so let's put that together. So we have our game. I think for this case, I'm going to go to config. I'm going to put my OpenAL stuff there. So I'll say from OpenAL import everything. Awesome. And then I'm going to initialize. Now the reason I'm defining this stuff in config is that we can like start and stop the game as many times as we want, but we only want to load the sounds once, basically. So I'll go smash sound equals oh yeah, by the way, so I've got this, and there's an SFX folder here that I've put in, and I've put in my sound effects there. Okay. So it's sfx / smash.wav. This will be okay, cool. So we've got those sound effects. So the only one which uses them is the board. Okay, so okay, so where are we clicking? Oh, not that, the board. Okay, so handle mouse click. So a click event has occurred and it is inside the thing. We can just call click sound dot play. And then the smashing will occur. Smashing will occur in the search. So we go search, down here, go smash sound, play. And I think that's almost all we need to do. Let's try this out. Perfect. I'm having fun. This is games. We're making games. Cool. We can click new game as many times as we want, and our memory usage will not go up because this is, come on. That's fun. I could do this forever. Okay, cool. All right, so that's it. That's it. Yeah. This has been a whirlwind tour of a lot of Pygame's bits, Pygame's libraries, some things we can do with it. There are more advanced features that I haven't touched on. This is just the beginner level. It's also quite a fast pace. So hopefully by the end of these videos, you're now confident to go out there and make your own game. And let me know, in the comments, or, I want to see what you do. If you want to take my game and remix it, change some things around, go for it. But yeah, that is it from me. Have fun. And yeah, bye.